Hey everyone, welcome to Undefined Coder. So today I'm so excited. We are going to tackle the lead code challenges one by one. So since we are starting out, I thought we should begin with simple problems. So I'm going to sort the problems with the difficulty, and we are going to choose the second one. That is palindrome number. Okay, let me just explain what's palindrome number. Before that, let me just change my code to JavaScript. Okay, palindrome number. What's palindrome? A palindrome word is when you read from forward or backward, it will be same. So, for example, you read this 1 to 1. If you are going to read from left to right or right to left, it's going to be same. So that's palindrome number. Let's take another example. -1 to 1. It's not same left to right and right to left because it has a minus negative in it. So let's read the question. Given an integer x, return true if x is a palindrome and false otherwise. So we have to return a boolean if it's palindrome or not. So yeah, let's start with the easiest method. In this method, we are gonna compare the original x with the reversed x, but we can't reverse an integer. We have to convert it into a string and split it to an array and reverse it and join back to a string. So I think you understand it. We are going to do all this with the help of inbuilt JavaScript functions. So let's start. So we are going to convert it into a string, and we are going to compare it with the reverse string. So this is how you reverse a string. So they have said that we have to return a boolean. So let's run it. Okay. So our sample test cases has been passed. Let's try submitting it. Let's see how it performs. So yeah, it beats 47 percentage of other algorithms, and you can see the stats. Yeah, it's good. I'm not saying it's bad, but we can improve a lot. So what makes an algorithm better? So there are two factors that makes an algorithm better. One is time complexity, and another is space complexity. So the time complexity for this algorithm is O of n, and space complexity for this algorithm is O of n. Actually, O of n is good, but we can make it better in this for this algorithm. So yeah, let's focus on the optimized algorithm. Okay, we are gonna now we are gonna do the optimized algorithm. So how we are gonna plan the optimized algorithm? We are gonna plan in a mathematical way. So we don't have to convert into string, and we don't have to use so much in JavaScript inbuilt functions. So in this, uh, let me tell you with an example. Let me take a palindrome number. So this is a palindrome number. What we are going to do is that we will split into halves. So this is first half and this is second half. And we will reverse the second half and compare it with the first half. So we can just compare it with the first half and the reverse the second half. We don't have to reverse the whole. We don't have to reverse the whole number. So we can do it this way. But there is an issue with this, that the length of this number is even. If the length of the number will be odd, it will be hard to do it. We can't take the exact middle from it. There's a 4 there, right? So what we are going to do is that we will simply ignore the middle number and compare the rest. We will ignore the middle number and compare the rest. So as you can see, it's the same. This is a palindrome number. I hope you understand what I meant by this. So let's move into the algorithm. So when we are going to write a good algorithm in an interviews, if you're going to write a good algorithm, you have to check. You have to definitely do these two things. One is you have to check for edge cases. So yeah, first let's start with the algorithm, then we can move to the edge case. So mm, what we will do, we will keep the second half of the integer to a let. Let rows. So while x is greater than reversed, this loop will continue. So we have to change the value of reversed. We have to take the last number of x into reverse. So what we're going to do is reverse. So we have taken the value of reversed, and we have to change the value of x2 because we are taking a last number of x to reverse, and we have to remove the last number of x2. So okay, I'll explain what's happening here. So if let's take an example. Okay. So in the first loop, the reversed is 0. 0 into 10 is 0, and x modulus of 10. What do you mean by that? So if you are going to do a x modulus of 10, we will get the modulus means remainder, right? So if you're going to do the modulus of this number, we will get the last number. The remainder will be 1. So we get the last number of x, and we will put it in the reverse, and we will remove the last number from x by doing divide by 10. So the divided by 10 will be like zero point 0.1, and if you are going to do math flow, it will remove the 0.1. So like that, we remove the last number from x, and uh, we will check the condition. If x is greater than reversed, yeah, of course x is greater than 1. So in the second loop, the reversed is 1, and we are going to multiply it with 10. So that means the ones place is going to change. It will go to the tens place. At first it was at ones. In the second loop we will multiply it with 10, so it will go to the tens place. And the third loop we will multiply it again with 10, so it will go to the hundreds place. Like that we are gonna, and we will take the last number from x. It's going to be 2, so plus 2. Then it will be become 12. and we will remove the last number, and like that. Whenever this x becomes 123, the reversed will also become 123. At that time, the x is not greater than reversed. It will be equal to reversed, so that this condition doesn't satisfy. Then this while loop will be broken. So at that time, we can return x equal to reversed. But there's an issue. As I said, this will only work if the integer's length is even. If it's going to be an odd number, we have to remove the last number, middle number, so that we can analyze properly. So what we're going to do is that, so yeah, as you can see, we have beaten 90% of the other algorithms. So we have started with the easy string method, but optimized it to a math-based approach. Actually, this is the kind of solutions interviewers are looking for: efficient, clean, and fast. So let me tell you why this algorithm is optimized. I have told you there are two factors that checks if the algorithm is optimized or not. One is time complexity, and the other one is space complexity. So what's the time complexity for this algorithm? It's O of log n. What is the space complexity of this algorithm? It's O of log n. It's much more optimized than the previous one. So that's why it beat 90% of the other algorithms. So if you want to know what's time complexity and space complexity, let me know in the comments. I'll make a separate video for that. So that's it for today. We have completed one more LeetCode challenge. And if you have any doubts, please ping in the comments and make sure to subscribe. Let's see you in the next video.